All right, so we started this yesterday, but as a reminder, we're doing polar graphs. Okay, these are the best way to prepare for these kinds of graphs is get familiar with those parent functions. So yesterday we talked about symmetry. We talked about how important and helpful that could be. If it has symmetry to the polar axis, that would be like your x-axis. That means I can fold it from top to bottom and it would overlap. In an equation, it means I could plug in a negative angle and it would go back positive. And specifically to a graph that would have polar axis symmetry would have cosine of theta in it. Then we talked about if it's got symmetry to the pi over 2 line. The pi over 2 line is like your y-axis. If you plugged in a negative theta, it would actually change the value, so it would change the sign of your value. And it pertains to something that has sine. And then you've got your pole axis, which means everything that's in the top right happens in the bottom left, and anything in the top left happens in the bottom right. And this would be like a negative, well, the whole thing would become negative. So if I didn't plug it in, if I didn't change the theta, I could get two answers here. And you'll see this with something, they're actually called limnoscates, which is not in this content. Something with an r squared could have polar axis. But also what are called roses, some of those will have pole symmetry. But we'll talk about that when we get in there. Then we talked about circles, and we said a circle has a parent, or the parent function of a circle, has an equation that is a number, and that number could be 1, so there doesn't have to be a number visible there. Okay, a number times the cosine of theta, or a number times the sine of theta. You're not adding and subtracting anything from this, okay? And that number on the front represents your diameter. Thank you. Oh, you're gonna wait. All right, so that diameter is literally from the 0, 0 point either to the right if it's cosine. If it was a negative a, it'd go left. And if it's a positive a in sine, that diameter goes up. And if it was negative, it goes down. So again, if you understand the parent function, then you really don't even have to plot points here. If you get stuck and you need to plot a point, you can obviously plot a point and see where it goes. But if you understand the parent functions, it's going to make it a lot easier.
Are we going to have to graph those in the test?
Yeah.
What if it's not like perfect?
I mean, it doesn't have to be perfect, but the diameter should be there, and then it should be somewhat circular.
Yeah, the diameter, but like the diameter.
The outside doesn't have to be perfect. Yeah. And you may, by the time test comes around, this might be a multiple choice question, but for the quiz, you're definitely going to draw it out. And for the test, you're going to definitely draw some of these out. But then some of them might be multiple choice. All right, so then we did this one, right? We said that this would have been a circle. We said it's cosine, which means it goes to the right, and it has a diameter of 3. So I would literally just plot my circle. I would plot my my diameter at 3. And I would make the best circle I could, okay? If that was negative, it would go left. If it was sine, it would go up. If it was negative sine, it would go down. And again, we could just check a point by plugging in 0. 3 cosine 0, cosine at 0 is 1, and it'd be 0, so that the r is 3 when the theta is 0. So that's how you can plot and double check. Questions on circles before we build, because we're going to keep going. Okay, then comes what are called limicons. And there are 4 different type of limicons. So if you are a visual person, this slide helps me. I literally can visualize this slide in my head, and I go from left to right, and I'll teach you the pattern. But these are 4 different types of limicons, and these are all if they're cosine. If they're sine, they turn so that the loop is at the top, or the cardioid is at the top, or the dimple's at the top, or the flat part's at the top, okay? These are all just examples of cosine. But the way a limicon is formed is you are adding or subtracting something from your trig function. So you would see something like 3 plus 2 cosine theta. Anytime you add, and you don't have, it could be 1 that you're adding. It could be subtracting in between. It could be after it. Okay, anytime you're adding or subtracting, it causes this shape. Now, the relationship between those two numbers is what causes the inner loop, the little sharp point, the dimpled edge, or the flat edge. So you're looking for A over B. A is now not your diameter, and that's where this gets confusing. The A is the vertical shift almost, where it normally is. That's your A. So the number that's separate from your trig function is your A. And then your B is the number that's being multiplied by the trig function. If A over B is less than 1, then it causes an inner loop. If A over B is equal to 1, they call it a heart shape, but it's called a cardioid. It does like that little sharp point on the inside, and then it's rounded up going out. If A over B is in between 1 and 2, then it's called a dimpled limison. It looks like a kidney bean. It kind of just puts in it a little bit, but it's a soft, rounded edge. And if it is greater than 2, it is a flat edge, as though you took that ball and threw it against the wall and it flattened out. So I said it at the beginning, but I'll say it again. For me, I visualize this slide. The smallest one is the inner loop. And then if you could picture somebody pushing that inner loop out, the next natural form would be this sharp point. If they push it a little bit further, the next natural form would be that rounded kidney bean shape. And then if they pushed it even further, the next shape would be that flat edge. So that's how I know less than 1 is the first one, and as it keeps going. So if I gave you that first example, which one's the A, the 3 or the 2? The 3 is the A. So A over B would be 3 over 2. Which range does that fall between? It's in between 1 and 2, which would be a dimpled limison. Okay? The next one, now my A is, it's 3, but we ignore the sign on it. Okay? For this, it will change the shape of, it will change the direction of your limison, but to figure out what kind it is, we ignore the sign. God bless you.
So both of those are the same type?
Correct. Yep. They would both be dimpled limisons. Okay. So now let's graph it. First of all, this is sine. So that tells you that your loop or your point or whatever is going to be at the top or the bottom, not right or left. What's the A here? 3. What's the B? 2. So what did we just say this would be? A dimpled limison. Okay, you don't need the accent, obviously, when you write it. Okay, then think about your symmetry. If it has sine, what kind of symmetry does it have? Pi over 2. So it's symmetric to theta equals pi over 2. That means anything that happens on the right-hand side of my graph is going to flip over and happen on the left-hand side of my graph. Now I will plot some points. And I'm going to plot points from the right-hand side of my graph. And then I'm going to flip them over to the left-hand side of the graph. So I'm going to start at 0, but literally you could even start at 3 pi over 2. I want to get points from this side of my graph so that I can flip it. It could have been reversed. I could have gotten points from pi over 2 to 3 pi over 2 and then flip it to the right. But that's how we're going to find those points. So I'm going to plug in for theta, 0. I don't need much, but I could do pi over 6. I could do pi over 3. I could do pi over 2. I could even put in there pi over 4, and we'll talk about why would I choose to do those things. And then I want at least something from the bottom. And so I can do 11 pi over 6, 5 pi over 3, and 3 pi over 2. But I'm going to try to see if I can see what's happening with the shape before I get to plugging in all those things. So I'm going to plug in 0. 3 plus 2 times sine of 0. What's the sine of 0? What's the y at 0? 0. So this is 3 plus 0, which is 3. Then I'm going to plug in pi over 6. 3 plus 2 times sine of pi over 6. What's the sine at pi over 6? 1/2. So this becomes 3 plus 1, which is 4. Then I'm going to go 3 plus 2 sine pi over 3. What's the sine at pi over 3? Root 3 over 2. The 2's cancel. What did we say we're going to approximate root 3 to be? 1 point, bigger than that. Maybe like 1.7, 1.8 if you want to make it rounded. So this would be like a 4.7. And then 3 plus 2 sine pi over 2. What's the sine at pi over 2? No, 1. You're doing over 4. Yeah. That will be your biggest point because 1 is the biggest value you can get for sine. So the A plus the A plus the B is going to be the biggest point you could get for your radius. All right, so now I'm going to plot these. So at 0, at 0, I go to 3. At pi over 6, I go to 4. At pi over 3, I go to 4.7. At pi over 2, I go to 5. Now, what did we say is going to happen on the other side? Same exact thing. So at pi over 2, I go to 2 pi over 3, sorry. I go to 4.7. At 5 pi over 6, I go to 4. At 0, or at pi, I go to 3. Have we gotten a dimpled side yet? No, which tells you that the dimple has to happen in the bottom. Does that make sense? This is my rounded side, and I expect a dimple to happen in the bottom. So I'm going to continue. I'm going to plug in points, and literally you could plug in the points here, or you could plug in the points here, and either way you're going to reflect it. So I'm going to plug in 11 pi over 6, and I'm going to plug in 5 pi over 3, and I'm going to plug in 3 pi over 2. So 3 plus 2 sine 11 pi over 6. What's the sine at 11 pi over 6? Good. And I get 3 minus 1, which is 2. Then I'm going to plug in 5 pi over 3. 3 plus 2 sine 5 pi over 3. What's the sine at 5 pi over 3? Negative root 3 over 2. So 3 minus root 3, which is, we're going to say is 3 minus 1.7. Good. And 3 plus 2 sine 3 pi over 2. What's the sine at 3 pi over 2? Negative 1. And 3 minus 2 is 1. Now I'm going to plot those points. So 11 pi over 6 is at 2. 5 pi over 3 is at 1.3. 3 pi over 2 is at 1. And then we reflect it. So 11 pi over 6 would be the same as 7 pi over 6. At 7 pi over 6, I go to 2. 5 pi over 3 would be the same at 4 pi over 3, so I go to 1.3. And now you can see your dimple starting to happen there on the bottom. It's going to come in. Oh, not so bad. I'm going to go all the way around first. All the way around.
When doing these, does our circle have to be good?
No. I mean, as long as you're connecting your points and as long as you can tell the difference between a dimple and a cardioid and a dimple inner loop, you should definitely be able to tell the difference. And a dimple and like where it's flat, the convex, as long as you can tell the difference, then it should be okay. So what questions like I've seen on the AP practice, I mean, you'll see obviously in your homework, but some of them are multiple choice, like which of the graphs is it? Some of them are describe the type of graph, and this would be a limison that is dimpled limison. It could ask you about its symmetry, okay? And then it could also ask you about like the interval on which this would not repeat. or would repeat. So if I kept going beyond, like if I plugged in all these points, right, from 0 to 2 pi, I get this natural shape. If I continue, what's going to happen to my points? Like if I plug in 13 pi over 6, I'm going to get a duplicate point. And so that range would start to repeat. Every time I continue to add on coterminal angles, my points are going to repeat. So it might just ask you to restrict your angles, and if you restrict your angles, you might only get half this shape. If it said give the, plot from 0 to pi, you're only getting the top part of this shape. So that you have to pay attention to as well. Questions so far? All right. Next up is a rose. At the end, we're going to do a couple more practices, but the next up is a rose. And a rose has petals, if you think about a flower, okay? A rose can have 3 or more petals. If it's 2, it's actually a different shape. It's called a lemniscate. So the smallest amount of petals it can have is 3. And the way you identify a rose from the equation is it will look like a multiple angle equation. There will be something multiplied by your theta. If that number is an odd number, then there are exactly that amount of petals. So if you saw something that said r of theta equals cosine 3 theta, then there are 3 petals. If that number is an even number, then we double it to get the number of petals. So r theta, or r of theta, equals cosine 4 theta, means there are 8 petals. The length of the petal is the A. So A is the length of each petal. A is the length of each of these petals. It's going to be your maximum radius. Whatever number there's on the front. If it's 5, that means you're going to go out 5 with your petals. If it was 2, you're going to go out to 2 with each petal, okay? So now these will either have, if they're an odd number, they'll either have they'll have symmetry to the pi over 2 line or to the polar axis, like these two. Notice it's cosine with a multiple angle. This is going to have symmetry to the polar axis. This one is sine with the multiple angle. It's going to have symmetry to the pi over 2 line. And then if it is even, it will also have pole symmetry. So whatever happens over here is going to duplicate down here. Whatever happens here is going to duplicate down here. So odd will have either polar or pi over 2, and even, it could have all of it. Even could have polar, and pi over 2. All right, let's graph one of these suckers. So this says graph r of theta equals 3 cosine 2 theta. You're going to find the symmetry, and this time we're going to find the zeros of the function. We'll go back and talk about that. So first of all, we know it's a rose because it's got a multiple angle in there. What do we know about the number of petals? It doubles. So how many petals are there this time?
4.
There are 4 petals. What do we know about the lengths of the petals? Good. The length is 3.
You double the
If it's even, you double it.
wait, what's even?
If the number next to theta.
You double, okay.
Yep, if it's odd, you keep it. If it's even, you double it. All right, so now what kind of symmetry does this have?
Polar.
It has polar axis symmetry because it's cosine. So whatever happens at the top is going to also happen on the bottom. Now think about the ways that could work with a rose. I could either have a shape like this, right? That would have polar axis symmetry. Or I could have a shape like this. That would have polar axis symmetry. So really, I just need to find one petal. And I can figure out the rest. So I am just looking for one place my R is what? How do I know I found a petal? What would my R be? What's the length of the petal? 3. All I need is one petal. So I could literally say 3 equals 3 cosine 2 theta. I'm going to find where my R is 3. Then I'm going to divide everything by 3. 1 equals cosine 2 theta. Now, do we remember how to solve these multiple angle ones? What am I looking for first? Where cosine is 1 and where is cosine 1? 0 and? Nope, just 0. Just kidding. Trick question. 0 and 2 pi if I kept going. Yeah, because look, it's going to say that, which we'll go back to when we find zeros. But it's 0 equals 2 theta, and then divide by 2. And theta equals 0. So when theta is 0, my R is 3, which means I have a petal here. And it has polar axis, which means, and there's 4 of them, which means my other petal is going to be here, and here, and here. And if I wasn't sure, how could I confirm this point exists and this point exists and this point exists? Plug in pi over 2 pi and 3 pi over 2. So if I plug in 3 pi over 2 into my original, not set equal to, but plug in 3 cosine 2 times pi over 2, 3 cosine pi. Cosine pi is what? -1. So when my angle is pi over 2, my R is -3. Is that inconsistent with my graph? No, it's just that it's that point, right? That would be -3 pi over 2. If I plug in 3 pi over 2, I get 3 cosine of 3 pi. What's cosine at 3 pi? Where is 3 pi? 3 pi is where negative pi is. 3 pi is where pi is, right? Which is -1. And that just got me this one. So it still gets you both petals. And then the last one's pi. If we want to check it, 3 cosine 2 pi. Cosine at 2 pi is what? 1. And now that's my last petal. So if you know these well, if you understand symmetry, if you understand the petal length, you can eliminate all that work. Find one petal and figure out your shape. If you are unsure or you don't know it well, now you have to go through the extra steps of finding those angles by plugging in. There was a hand. What was the question? Did I answer it? Yeah.
Wait, when you do theta, is theta on your x or on your y?
Theta is your, when you're plugging in, you mean?
Yeah.
So when you're finding the equation, like when you're actually solving this, you're using the unit circle values there.
But when we found like theta, when we found like where r is.
When you're solving for theta, that's, so this coordinate point, we R was 3, theta was 0. So that's our polar coordinate point. You're welcome. Okay, now this also says find the zeros of a function. How do you find the zeros of a function? Not plug in, set equal. So I would say 0 equals 3 cosine 2 theta. How do I solve it? Divide by 3. 0 divided by 3 is 0. Where is cosine 0? Pi over 2 and 3 pi over 2. So 2 theta equals pi over 2. And 2 theta equals 3 pi over 2. Now it gave me an interval this time, so I'm not adding it on. I'm not done. Yeah, no. Now I got to divide by 2 or multiply by a half. Yep,
How did you establish that there was polar axis symmetry?
because it has sine in it. No, cosine in it.
But I thought you said it had something like on the theta, like that didn't automatically.
No, it does. It might also have pole symmetry.
Would you have to say it did?
I mean, this one does also have pole symmetry. So if it asks what's the symmetry,
What's pole symmetry?
like whatever's happening in the top right gets duplicated top left, top left. If it's even amount of petals, it has pole symmetry. Yeah. So listen, because this is important. Like when you see a multiple choice question, and this answer is not the only answer here. It's going to say something like 0 equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Why does that happen? So what would happen is that we've adjusted our interval of how often this answer happens by making it a multiple angle, right? So let's say we had found it with the interval. Let's say this initial part was not here. Then my answer 2 theta would have equaled pi over 2 plus 2n pi. And 2 theta would have equaled 3 pi over 2 plus 2n pi. And then both the angle and the interval gets adjusted, right? We did these on the last test. This is pi over 4 plus n pi, and this is 3 pi over 4 plus n pi. So if the interval was not given, those would have been my answer. But because the interval is given, you actually have to find the angles that meet those intervals. So it is pi over 4 plus 1 pi, which is 5 pi over 4. And that still lies between 0 and pi and 2 pi. And it is 3 pi over 4, but it's also 3 pi over 4 plus pi, which is 7 pi over 4. And that also falls between your interval, which was, I wrote all over it, but it was negative pi over 2. No, it was 0. To 2 pi. So these will not be open-ended questions, but they will be multiple choice questions, and you will go to find your answer and you'll be like, whoa, there's more answers there than just my original. And that will remind you that you have to check for your other answers. So my advice, and when I teach this, like we do this in actual pre-calc honors advanced, is that I say solve it as though there's not an interval given to you first. So add the interval on. And then actually find those angles using your updated interval. Maddie?
So for those, do you not have to plug in points?
Not if you know what you're doing. If you don't know what you're doing, then you're going to have to plug in some points. But if you know to look for a petal, and you know how many petals there are and what kind of symmetry is, then you really don't have to do anything else. Yep.
For when it's on cosine 2 theta, I thought you had to do like those things that had like 3 rules for cosine. Like it was like cosine squared minus sine squared.
No. That would be your double angle formula. So, but you don't have to do that when there's just one double angle, you solve it. That would be like if it's a mix of a double angle, like if it said cosine of 2 theta and there was a sine there. Now I have to replace the double angle one.
What would
You'd get that. You'd actually get the same answer by replacing cosine of 2 theta with, you could do any of those 3.
Would we ever have to do that?
No, not on this stuff. It will show those kinds of things are going to show up in the verifying questions. Yeah. All right. Last one is called a spiral. Okay? And a spiral looks like a spiral. A spiral is r equals theta or some sort of relationship with theta. It could be 2 theta. It could be theta over 2. It could be 2 over theta. But there is no sine or cosine in these. Like this equation will not have a sine or cosine. So it will not have symmetry. Okay? And it creates a spiral. And let's think about why it creates a spiral. If my equation is r, actually it would be r of theta, equals theta itself, then what is r at 0? So if my theta is 0, what is r equals 0. That's it, right? I don't have to do anything to that. So if my equation, r of theta equals 0 is given, and I plug in thetas, and I start at 0, I literally get r of theta equals 0. So if my theta is 0, my r is 0. If my theta is pi over 4, what's my r? Pi over 4. Now what is pi over 4? 3.14 divided by 4, which would be this is 7.78-ish, because it would keep going, okay? So that's less than 1, which is where that little dot is there. What is my r if theta is pi over 2? Pi over 2, what's 3.14 divided by 2? 1.57. Wait, this is 0.78. And that is what's happening up here. So as you go around your circle, when I hit pi, it'd be 3.14. When I hit 3 pi over 2, it'd be 1 1/2 times pi. When I hit 2 pi, it's going to be 6.28. So as I increase my theta, what is also happening to my r values? They are increasing. So they are not increasing like in an equal interval, which is why this is literally causing this spiral. If I kept going, it would keep getting bigger and bigger and bigger. The bigger the theta, the bigger the r for a spiral. Now, obviously, if there was a negative in front, it would change this. If there was something like, you'll see something in the homework tonight that says like r of theta equals, I think it's theta over 2, or it's 2 over theta. Now it's going to change it, right? Theta over 2, are those values still increasing? If I take a number and I divide it by 2, but I keep dividing the bigger number by 2, are those values still increasing? Pick a theta. Let's start with 0. 0 divided by 2 is what? 0. Now pick up an easy theta. 2 pi divided by 2, which would be? Pi. Are those values increasing? Yes. What happens if it's the reversed? No, I can't pick theta. I can't pick 0 because it will be undefined. But let's say I picked pi over 2. This would be 2 times 2 over pi. This would be 4 over pi. And then if I pick a bigger theta, 2 over pi, what's bigger, 4 divided by pi or 2 divided by pi? So what's happening to those values? They are decreasing. So if you don't know, plug in some values and see what's happening. If theta is in the top and it's being multiplied by something or divided by something, those values are going to increase and cause the shape to look like this. If they are decreasing, now my points are going in the other direction. They are going to the spiral in the other direction because my thetas are going to be decreasing. So there is a question, multiple choice, about like, what does this graph look like? Literally, your answer is just that it's a spiral, okay? But then what is the relationship between the values? As your theta is increasing, your r is doing what? A normal spiral, the r is also increasing. But if I do if the theta is in the bottom, now they're decreasing. Yep. All right, so when you see this, again, hopefully these are easy to spot because they don't have sine or cosine. I know already it's a spiral. If I'm multiplying by things that increase, are my values increasing? Yes, so I know these values are going to get bigger. At 0, what's my point? 0. Go to like pi over 4. What would 2 times pi over 4 be? Pi over 2. And we said pi over 2 was like 1.78. So pi over 2 could be 1.78. Oh, no, that would be pi over 4. Sorry, I plugged in pi over 4. Then I can plug in pi over 2. And we said this would be pi, which is 3.14. So when I plugged in pi over 2, I got 3.14. So my spiral is going to look something like this, okay? I do not expect these to be perfect. I would say you're probably very rarely going to have to draw. Like I said, on your quiz, I'm going to have you hand draw these. But beyond that, you are probably picking these from a multiple choice question. And you should be able to identify that that's a spiral. Questions on that one? Okay. Last one. See if you can do it. Identify what kind it is. Start with type and symmetry. What type is it? It's a limison. The A and the B are both the same, right? So this is a cardioid. Cardioid, which looks like a heart. Like cardio, like your heart, right? Limison. How about symmetry? What kind of symmetry does it have? Polar axis. So it's either going to look like this-ish or it's going to look like this. Okay? So you only have to plot points from the top and then reflect it over the bottom, or the bottom and reflect it over the top. All right, so we said it has polar axis symmetry. So I'm going to plot points from the top of my unit circle. And then I will reflect it to the bottom. So if I grab angles from the top, obviously I'd start with 0. 2 minus 2 cosine 0. Cosine of 0 is 1. 2 minus 2 is 0. And I already found the point of my heart. I just don't know, like obviously it should come in on either the right side or it's going to come in on the left side. And you'll know that literally as soon as you find the next point. So you can plot pi over 6, pi over 4, pi over 3, or any combination of those. Like we plotted pi over 6 and pi over 3. You could jump to pi over 4 if you're secure in what your shape looks like. When you're not, that's when you're going to plot the extra one. So 2 minus 2 cosine pi over 6. The cosine at pi over 6 is what? Root 3 over 2. So this is 2 minus 1.7 or 0.3. Then I go pi over 3. So 2 minus 2 cosine pi over 3. Cosine at pi over 3, 1/2. And that's 1. And then pi over 2. 2 minus 2 cosine pi over 2. That's 0. And that's 2. And that's where your biggest point is. Remember, your biggest point is going to be where the radius is fully extended would be where your cosine is where they add up together. So I know that it's going to, no, that's not true. Sorry. Because the sign could change. It's going to get bigger on the other side. That's where the biggest point before it goes out to the other side would happen. So pi over 6 is going to be 0.3. It's small. It's down here. Pi over 3 was 1. Pi over 2 is 2. This is not 1. This is 1. Okay. And I know that shape is already beginning the shape there. If I were to reflect it over down on the bottom, then at the pi over 6, it's going to be at 0.3. So 11 pi over 6, it's going to be at 0.3. At the pi over 3, which is 5 pi over 3, it's going to be at 1. And at 3 pi over 2, it's going to be at 2. And that is the other side of that heart shape. So I expect my curve to come out and come around, which means I can kind of eliminate some points. I don't need to do 2 pi over 3 and 5 pi over 6. Maybe I just do the pi over 4 there. So I would do 2 minus 2 cosine 3 pi over 4. 2 minus 2, the cosine of 3 pi over 4 is negative root 2 over 2. These cancel, and I get 2 minus a negative, so it becomes plus root 2. Root 2 we approximate as 1.4. And that's 3.4. So at 3 pi over 3 pi over 4, it's 3.4. And then I'm going to jump to pi. 2 minus 2 cosine pi. 2 minus 2 times negative 1. And that's my biggest point when those two get added together, which is 4. And then I can reflect it down here. And I can fill in the rest of the heart shape. Awful bottom, but you get it. Okay? It was warm, yeah. All right, now it asks for the zeros. How do we find zeros? Set it equal to 0. So I'd get, subtract the 2, negative 2 equals negative 2 cosine theta, divide by negative 2, 1 equals cosine theta. Where is cosine theta? 1 between 0 and 2 pi, including 2 pi, because it says or equal to. 0 and 2 pi. So those would be the zeros of this function. All right, I'm going to show you how to graph this on your calculator purely so that you can check. I highly doubt you are going to have an opportunity. I know not for me, but I'm almost 100% sure this type of question will not be on the graphing portion of your exam because you could literally just graph it. But I'm going to teach you how to do it just in case and so that you can try to check your answers as you're going. So one of the things you have to do, or the most important thing you have to do, is switch your mode. So our mode, if you go to and you look at your mode screen, it stays in radians, but look underneath radians, it says function, parametric, and polar. You have to put it in polar. So I change that to polar, and when I do, my y equals actually turns into an r equals, and my x button gives me theta instead. It knows to switch those variables. So you literally just type it in 2 minus 2 cosine, the x button will give you the theta. And then you hit graph. And you get your little heart shape. Now this is restricted. If I wanted to restrict it, I would have to restrict my window. If I wanted to only restrict it, this is going to give you a repeated curve. So it's always going to look the same, right? But let's say it only wanted to know what was happening from 0 to pi. Then you have to restrict that as your x values because your x values are your thetas. So right now my x min is 0 and my x max is 6.28. This is from 0 to 2 pi. Okay, if you wanted to change it, that's how you change it.